Video, we are going to discuss more L'Hopital's rule. Number 7, we have limit as x approaches to 0 from the right. We have arctangent 2x, which is an inverse tangent, divided by ln x. So what is the graph of arctangent 2x? Arctangent 2x, this is what the graph looks like. It is sandwiched between two horizontal asymptotes, one at pi over 2, and then one at negative pi over 2. So this is what the graph looks like. So that is arctangent. All right, and then what happened as x approaches to 0? So as x approaches to 0 from the right, we are talking about this piece, right? So y approaches to 0. What about ln x? This is the graph of ln x. And then we have a vertical asymptote. As x approaches to 0 from the right, the limit approaches to negative infinity, right? So this is equals to x, y approaches to 0 from the right. That is something a little bit greater than 0. And then divided by negative infinity. So what is that equal to? 0 divided by any non-zero is equals to 0. That's it. So this is not 0 over 0 or infinity over infinity. So don't even think about L'Hopital's rule. So that's the first problem. I picked this problem is because I want to show you that you don't always have to apply L'Hopital's rule. Sometimes the limit can be evaluated without L'Hopital's rule. And then the next one, we have a function times another function. Number 8, we have limit as x approaches to infinity of x times sine of a pi divided by x. So pi divided by x, when you plug in infinity, what is going to happen? When you plug in infinity, so you have an infinity, right? Times sine of pi divided by infinity is equals to 0. Sine of 0 is equals to 0. So you have infinity times 0, right? That is not equal to 0. This is one of the 7 indeterminate form. So this is one of the 7 indeterminate form. So that cannot be determined. But this is the problem. I have 0 times infinity. So based on L'Hopital's rule, if you have 0 times infinity, yes, that is indeterminate form, but I am not able to apply L'Hopital's rule. Because in order to apply L'Hopital's rule, we are only allowed to have infinity over infinity or 0 over 0, which is not the case in here. So how do we do L'Hopital's rule here? The reason I picked this problem is because when you see this, when you encounter this situation, you have to make a 0 over 0 or infinity over infinity. So here is how we are going to rewrite the function. So limit as x approaches to infinity, I am going to keep the sign on top. And then the x, I am going to change that to 1 divided by x. All right. Do we have 0 over 0 this time? So when you plug in infinity, the top is sine 0, which is 0. And then the bottom is 1 divided by infinity, that is equals to 0. So now I can do L'Hopital's rule. All right, that's why I picked this problem. And then we go ahead and apply L'Hopital's rule. So we have limit as x approaches to infinity. The derivative of sine is cosine pi over x, and then using chain rule, you take the derivative of the inside, so you have pi times x to the negative 1. So the negative 1 goes down, then you have pi divided by x squared. The derivative of 1 over x is negative 1 divided by x squared. All right, so that is the result of the L'Hopital's rule, and then we are not going to rush to do another L'Hopital's rule. I want to clean up the fraction. Okay, so we have limit as x approaches to infinity. You have cosine of pi over x. So each of the fraction has an x squared in the denominator, and there is a negative. So that means I am able to cancel out the negative sign, the negative 1. Also, I am able to cancel out the x squared. So you have a pi, and then this is divided by 1. Do we still need to apply L'Hopital's rule? The answer is no. Once you plug in infinity, pi divided by infinity, so 3.14 divided by infinity, that is just equals to 0. So overall, you have cosine of 0 times pi divided by 1, right? So cosine 0 is equals to 1. So 1 times pi divided by 1. So overall, the limit is equals to pi. All right, so let's take a look at the next one. The next one we have number 9. We have limit as x approaches to 0 from the right. We have 1 divided by x minus 1 divided by e to the x minus 1. So plug in x 0 plus, so a little bit more than 0. Then you have 1 divided by 0 plus, and then e to the 0 power is 1, right? So e to the 0 power is 1. So e to the 0 power, this is e. This is a 0, a little bit more than 0. That means you have a point right here that is a little bit more than 1 minus that. Then you have something a little bit more than 0. And then what about 1 divided by 0 plus? It's like 1 divided by this. What is that equal to? That equals to infinity. So this is infinity minus infinity. Then this is one of the 7 indeterminate forms. All right. However, infinity over infinity, we are not able to do L'Hopital's rule. That is impossible. In order to apply L'Hopital's rule, we are only allowed to have infinity over infinity or 0 over 0. All right. So when that happens, let's do some rewrite. So for example, I can make a common denominator. So this is limit as x approaches to 0 from the right, and then common denominator x times e to the x minus 1. So this will be a e to the x minus 1 minus x. All right, so now we have one fraction. Plug in zeros to see if you have one of these indeterminate form, right? E to the 0 is 1, so 1 minus 1 minus 0, the denominator is 0, and then 1 minus 1, it looks like we do have 0 over 0, so it is safe to apply L'Hopital's rule, and then we just apply L'Hopital's rule. So x goes to 0 from the right, and then the derivative of the top, the derivative of e to the x is e to the x, the derivative of 1 is 0, the derivative of x is 1, and then the bottom, you have to do what rule? You have to do a product rule, fg prime plus gf prime. So fg prime, so that will be x times the derivative of the parenthesis, so that is e to the x minus 0, and then plus g, that is e to the x minus 1, the derivative of x is equals to 1. Let's expand the denominator. So we have x approaches to 0 plus, the top is e to the x minus 1, and then we have x times e to the x plus e to the x minus 1. All right, and then do we have an indeterminate form? Let's try another plug-in. E to the 0 is 1 minus 1, and then 0 times 1 plus 1 minus 0. Oh, no. Yes, e to the 0 is equals to 1, and then the last one is minus 1. So looks like we have 0 divided by 0, so it is safe to apply L'Hopital's rule again. Then we just apply L'Hopital's rule. So this is limit as x approaches to 0 from the right, and then this is e to the x, the derivative of 1 is 0, and then this one is a product rule, so that is fg prime, and then plus gf prime. The derivative of e to the x still e to the x, the derivative of 1 is equals to 0. Okay, so let's see if we are able to do the plug-in. I believe the answer is yes. So e to the 0 is 1, right? E to the 0. So this is a 0, E0, E0 plus E0. Then that will be 1, 0 plus 1 plus 1. So that is equals to plus 1, that is equals to 1/2. So that is the answer of number 9. So in the next video, I will do 3 more limits. I see you in there.